So this one is a very beautiful question. Let's go and check it out and then help you to understand what you guys can do. It was one of the questions that was sent to us via the app by one of the learners who sent this question and wanted assistance with this. So the question reads as follows: calculate P if we've got the sum of 27 times P to the power K equal to the sum of 1 minus T squared from T equals to 2 up to 5. So this is a very exciting content because it's something that is new for you as a grade 12 learner. Even though this show is specifically created for grade 12 learners, there's a lot of things that grade 11 learners can also benefit if they keep watching. So encourage them also to join us here. They'll definitely benefit a lot from what we are doing here. Okay, so the most important thing that you need to understand when you've got a question such as this one is to appreciate the fact that the symbol that you are sitting with there, that sigma notation symbol, is simply asking you to work out the sum. So the entire question is just about figuring out the sum, right? So if you look there on the left hand side, I must work out the sum, and on the right hand side I must also work out the sum. So I am actually required to work out the sum. The order of simplifying a question like this will always be: number one, you will need to expand what you are sitting with. You'll need to first of all expand and get the actual terms that are appearing in that particular sigma notation question. And then after expanding, next thing that you'll need to do is you will need to add those terms. And then after that, your algebra will take over from there. You'll be able to simplify and find whatever the unknown we could be interested in. So on the left-hand side, what are we actually interested in? We want you to first of all find the sum of a certain number of terms. So let me follow the guideline that I'm giving you that says, first of all, we need to expand. So on the left-hand side, I'm going to expand. Now, many people might be confused by the fact that if you check on the left-hand side of the equality sign, we've got two different variables. There's the variable P and there's the variable K. So the variable that we are replacing, or the one that we are substituting values for, is K, because you can see in your sigma you've got K equals to 1 appearing there at the bottom. So what I'm simply going to do is I'm going to keep writing 27P to the power of some exponent. So let's see what will happen if we do exactly that. So I'm going to write here that on the left hand side we're going to have 27, and then we are also going to have P to the power of 1. We were told that we need to start substituting K with 1. After that, I'm going to say that must be added with 27 P to the power of the next value that P is going to take, K is going to take will be 2. And then after this one, we'll then have again 27 P to the power of the next value of K is just simply going to be 3. So I can continue playing this game forever and ever until the second coming. But of course, we've got infinity and you will never get there. So what I'm simply going to do is I'll stop there and put those 3 dots you see at the bottom to tell you that this can go on and on until we get to infinity. On the right hand side, I'm going to do the same thing again. This one has to be t values that are substituted. So I'm going to write 1 minus my first t value is supposed to be 2. So I'm going to have here 2, which has to be squared. So this is the first one that I'm getting. If you check there, term 1, I'm going to get 1 minus 2 squared. And then that needs to be added with 1 minus the second term that I'm putting there will have to be 3 with a square again, right? And then I have to put 4 as well. So I'm going to write 1 minus, let's put 4 squared, and then plus 1 minus, then we're going to put 5 squared. You will notice that I started substituting my t value at 2 because we were instructed to start substituting at t equals to 2. And I'm going to stop after substituting my t as 5 because we were told at the top that we need to stop when we get to t equals to 5. So those numbers are the ones that guide you in terms of where you need to start and where you need to stop. So the first value was t equals to 2, then t equals to 3, then t equals to 4, then t equals to 5, then we stop there because we're required to stop when we get to t equals to 5. Right. Now, once you are done with this substitution, the next thing to do is just add whatever you have on the left and add whatever you have on the right. And then from there, your algebra is going to take over. You'll be able to find the solution of this variable p that the examiner is asking us to work out. So the rest of what I'm going to do is not at all what is related to grade 12's work. It's grade 8 and grade 9's work, how to add terms and how to actually add like terms and how to solve for an unknown in a linear equation. All right. So let's see how we can finish off this question. On the left-hand side, I've got 27p to the 1 plus 27p to the 2 and so on and so on. So you need to acknowledge the fact that we are required to add the sum of infinite terms. And we know this for a fact because the number, the value on top there of the first sigma notation on the left is actually infinity. So that tells you that we need to use the formula for summing terms to infinity. And you'll agree with me that formula for sum to infinity is actually given by a divided by 1 minus r. Okay, now on the right hand side, all those are just numbers, so let's write them down. The first one is minus 3, and then the second one is 1 minus 9, which is minus 8. The third one is 1 minus 16, which is minus 15, and the last one is 1 minus 25, which is minus 24, right? And then if you go on the left hand side, you will notice that we need to know what is the A value of this particular sequence that we are dealing with, the series in fact. So the A value is always the first term, and it was given to us as 27p. So I'm going to put 27p for A on the numerator, and on the denominator I've got 1 minus the ratio. So you get the ratio when you take term 2 divided by term 1. So let's try and work out that R. So we know for a fact that R is always T2 divided by T1, which in this case is going to be 27p squared divided by 27p. When I take term 2 and I divide that by term 1, and then you will see that the answer will just become a value of p. So my ratio is going to be p. On the right hand side, if you add all those terms, minus 3 plus minus 8 plus minus 15 plus minus 24 is just going to give you a value of negative 50, right? Okay, cool. And then from here, it's just simple algebraic simplification. I'm going to put this one over 1, and then I'm going to just simply try and cross multiply to see what the final solution is going to come out as. Okay, cool. So when I cross multiply here, I'm going to be sitting with a negative 50, right? This one's times those ones there, multiplied by 1 minus p equals 2. Then 27 times p is going to be 27 times p multiplied by 1. It remains the same thing. Right, and then after that, we are going to multiply yourself in here. You're going to get minus 50, and then this one is going to give us positive 50p is equals to 27p. And then if you make p the subject of the formula by leaving 50 here and taking 27p minus 50p as what appears on the right hand side, you'll then have minus 50 equals to 27 minus 50 is going to give us minus 23p. And then you can simply divide both sides by minus 23, divide this side by minus 23 as well, and then eventually your final answer comes out as p equals to 50 divided by 23, and that will be the solution to the value of p. Now, it's not a very complicated question. It's absolutely straightforward. We'll be testing a couple of things in this question. Are you able to expand sigma notation terms? Are you able to add them? And in addition, do you understand how to work out the sum of an infinite term? And the other thing we were also testing was, are you able to solve a linear equation? So once you combine all those concepts, you will be able to solve a question like this. It is not at all complicated. Don't let it intimidate you or confuse you. Always make sure you understand the basics, because any question they ask you is always doable if you just take yourself back to what do we normally do when we have to worry about that question. So in this case, we had to expand the left and expand the right, and then you add the terms on the right, you get minus 50. You add the terms on the left-hand side using the formula for sum to infinity. When you've got too many of them that you need to add, that's where your formulae for summing a series comes in. So thank you very much for sending us that question.